Okay, this last section that we're doing is called inverse variations, or just variation functions. These are all going to be word problems. And the first thing you guys need to do is write down this table that is here. This is the vocabulary, or the action words, in which will tell you what type of equation to look at. If we're talking that something varies directly, it's just straight across problem. So y equals k times x, where k is some type of constant. In most of these problems, we're going to have to try and find out what k is, and there's techniques to doing that will show. When it says varies directly with the square, it's referring to this, where x is squared, not just to the 1, like directly. And then, of course, it can directly vary with the cube. If it says inversely varies, then what we're talking about is that y equals some constant divided by x. Or another way to think of that is that this is equal to k times 1 over x. Okay, so you want to go ahead and make this table, make this chart, and put it inside of your notes, because you guys are going to be going back and forth to this. I'm going to do 2 different examples. The first one is both problems are from the book. Okay, the first one I want to look at is the intensity of light reaching you from a light bulb depends on how far you are standing. The best thing to do is to, that doesn't help. There we go. Best thing to do is to come through and try and really get all the information that you can. So I like to try and underline or highlight. I know you're not supposed to be writing in the books, but a lot of people already have, so I don't know. Just don't do it when I'm looking, I guess. So a light bulb depends, the intensity of the light bulb depends on how far the bulb you are standing. Suppose that the 3 meters the intensity is 120 and 6 meters is 30. So this is giving us 2 points in which you are 3 meters away and 120 is the intensity. And this one you are 6 meters away and the intensity is 30. The question is, as x gets bigger, what's happening to our y's? Well, they're getting smaller. Okay, so this is going to indicate that we have some type of inverse variation. Okay, so if we are going to write just a general equation, it would be the intensity equals k divided by some x. Okay, now we want to find a particular equation. To do that, we are going to take one of the points that we got, okay, and we are going to plug it into the equation. So we'll take 120 equals k over 3. And then we're going to solve for k. Multiply this by 3, that should give me 360 equals k. To answer part B, find the particular equation. I just found k, so now I just make my equation. I equals 360 divided by x. Here is my particular equation. The next part says is predict the intensity at 10 meters. We're just going to plug in for x. So we let I equal 360 divided by 10, which gives I the intensity of 36. The next one is predict the intensity at 12. You guys are going to do the same thing, but plug in for 12. Predict the distance in which the intensity will be 4 units. To do that, we have to go back the other way. So we're going to say 4 equals 360 divided by x. We can multiply by x to get 4x equals 360. And if we divide by 4, we get x equals 90. So for part E, we would say, for part E, we would say you have to be 90 meters away, and you would see an intensity of 4 meters. Let's see. Draw the graph. We don't need to be drawing the graphs on these word problems. I don't want to be doing that. Okay? So that's one example. I'm going to go ahead and erase all this and do one more. So the number of pounds UA is directly proportional. Okay, so here's this keyword, directly proportional, to the number of kilograms you are. K dense steps onto a scale calibrated for kilograms and finds that she is 50 kilograms at 110 pounds. What I read from here is that I have some point in which if you put in 50 kilograms, you will get 110 pounds back. We're going to need to use this point later on. First thing is write a particular equation of pounds in terms of kilograms. I was told this is directly proportional, so my general will be pounds equals K times kilograms. So if I want to make a particular equation, I'm going to use these points that I got. I'm going to plug in 110 for my pounds equals K times the amount of kilograms, which was 50. For these problems, I'll allow you guys to have decimals. Decimals are okay. If you do the division on this, you get 2.2 equals K. This will be able to build our particular equation now. So pounds equals 2.2 times kilograms. That would be part A, our particular equation. How many pounds would each person weigh if the scale read 110 kilograms? We're just going to plug in. So P equals 2.2 times 100, which will give me that this person weighs 220 pounds. I'll leave the others to you. This one's nice. C is cool. How many kilograms would Stan Dupe be if you weighed 165 pounds? We're given the pounds in this case, okay? Or you can build, we want to know what the kilograms for Stan would be. So what we'll do is we'll plug in 165 equals 2.2 times, kilograms, sorry. Kilograms. Let me pull out my calculator. 165 divided by 2.2 equals 75 equals kilograms. So Stan would be about 75 kilograms by my calculations. How many kilograms are you? You guys can do that at home for a little extra practice. Plot the graph. I don't need you guys to plot the graph. And F, what quantity the proportionality constant represent in the real world. I don't need you guys to be doing these questions yet. The only thing I want you guys working on right now is building these equations and knowing what this information does and how we manipulate the equation with it. If you guys have any comments or questions, please let me know. We'll have all week to be working on these.